Welcome to In 5 Minutes. In this video clip, we will discuss the low level modulation, which is LLM transmitter. As we have discussed before, in LLM transmitter, the modulation will take place at low power levels. In other words, modulating signal and the carrier signal will not be power amplified before the process of modulation, and hence the output of the modulator, which is double sideband full carrier, will consist of low power content. The power of the transmitted signal has to be of minimum specific value, and hence to increase the power content we will send the output of the modulator through series of power amplifiers. Let us discuss the transmitter block diagram in detail. This time the upper branch of the transmitter deals with the carrier signal. We have RF carrier oscillator, which will be generating high frequency carrier signal. Buffer amplifier will provide impedance matching between the two blocks. Carrier driver will boost the current content of the carrier signal. But please remember that none of these blocks will provide power amplification to the carrier signal. So we have carrier signal available at the input of the modulator, but it is of low power content. From the lower branch, we can see modulating signal source giving rise to modulating signal, which could be microphone, for example. Now the output of the modulating source could be of very low amplitude, and hence we may need a pre-amplifier, which will be in the form of a voltage amplifier. So it simply gives voltage amplification to the signal. And modulating signal driver, apart from providing impedance matching like buffer amplifier, will increase the current content of the signal before it goes to the modulator. But again, I repeat, all these blocks will not provide any power amplification to the modulating signal as it reaches to the modulator. So we have the carrier and the modulating signal present at the input of the modulator. The output of the modulator will be nothing but AM signal, in this case double sideband full carrier, which will be of low power content because the modulation took place at low power level. Now this signal has to be power amplified, and hence we pass it through a series of power amplifiers. For example, we have linear intermediate power amplifier, linear final power amplifier. So intermediate, final simply represent various stages of power amplifiers. When I say linear power amplifier, it is a power amplifier which does not introduce high amount of harmonic distortion in the signal. For example, class B push-pull power amplifier is the amplifier which helps us in avoiding the harmonic distortion by cancelling out all the even harmonics. In the process of cancellation of even harmonics, it mainly cancels out the second harmonic, which is the major reason of harmonic distortion. And hence use of amplifiers like class B push-pull power amplifier keeps the operation of power amplification very much linear, although it is not completely linear. So the linear power amplifier here simply mean that we try to avoid harmonic distortion as much as possible. Power amplifiers like class C power amplifiers have very high efficiency of power amplification, but they are highly non-linear also, because if you remember class C power amplifier, the non-linear device, the amplifying device, is biased below the cutoff, and the power amplification takes place with the help of generation of current pulses and sending those current pulses through the tank circuit. Something similar to flywheel effect that we have discussed in the previous clips. So class C amplifier, even though it has high power efficiency, is not suitable for power amplification of DSB-FC signal, simply because it is highly non-linear. So we prefer linear amplifiers like class A or class B push-pull amplifiers. Class B push-pull amplifier has more power efficiency compared to class A power amplifier, and hence we may use it for the power amplification. Output of the last power amplifier will be DSB-FC with large power content, and again through a coupling network it will be transmitted through the antenna. Coupling network will provide impedance matching so that the maximum power transfer takes place from last power amplifier to the antenna.